Alright guys, here's the video for adding and subtracting radicals. Remember we talked about these 3 steps when we're wanting to combine our radicals through addition or subtraction. We want to simplify all the radicals, identify radicals that have the same index and the same radicand, which is the number underneath the radical. That is the only time you're allowed to combine them. Once they have the same index and the same radicand, you can add or subtract the coefficient, which is the number in front of the radical, but the radical is treated like a variable and it will remain the same. Remember I showed you the example if we had 3 square root 5 plus 5 square root 5. This is really no different than if I had 3x plus 5x. The radicals are the same index and the same radicand, so they're treated like a variable. The x remains unchanged, but the coefficient in front changes, so 3 plus 5 is 8. So if I were to combine those, I'd have 3 plus 5 is 8, and then my radicand remains unchanged, root 5. Okay? So they're very rarely am I going to give them to you where they start off the same, so you're going to have to simplify them to see if you can make them be the same. Alright, so 20 looks like it should be able to break down. So when we look at it individually, we have 2 times 10. The 10 will definitely break down again, so I'm going to rewrite it as 2 times 5. And then I go and look for pairs. I have a pair of 2's. And when you're taking a square root, your index tells you how many you're looking for. We're doing a square, which is 2. I got 2 2's, so a single 1 comes out to multiply to the coefficient that's already in front. This 5 does not have a pair, so he has to remain underneath the radical. So I end up with 2 times negative 2, which is negative 4 root 5. On my other term, 5 is a prime number. It won't break down, so we're just going to bring him down. Minus 2 root 5. Now I have same indexes, same radicands, so I can just combine the coefficients, which is negative 4 minus 2 is negative 6, and then root 5. You will follow the same process on every single problem. Some problems are shorter with less terms, some problems are longer with more terms, but it follows the same every single time, same process. So if we look at number 1, 1 is nice because their radicands are already the same, their indexes are already the same. All you need to do is combine their coefficients. So their coefficient is 3 minus 2, which leaves 1, and the radical, root 6. You do not have to write the 1. Some people like to write the 1, especially when we're adding and subtracting. It's important to remember that that is in fact a 1 in front of there. An example of that is number 4. I told you to star this one because one very much like this might show up on a test or quiz sometime soon. So let's look at our 2 terms. They're definitely not the same radicand. They are the same index, so we're good to go ahead and start at least seeing if we can make them look alike. 15 could be rewritten as 3 times 5, but this doesn't help us. I don't have any pairs, and when that happens, you just put everything back together and put it back the way it looks. So it's just going to stay radical 15. But 60 we know will break down. So 6 and 10, you can pick any of the factor pairs. You'll get the same answer no matter what. 6 can be rewritten as 2 times 3. 10 can be rewritten as 2 times 5. And then we want to look for pairs. I got a pair right there. Well, 3 kind of went in front of us. But we have a pair of 2's, which means a 2 can multiply to the coefficient that's already there. And then we have this 3 and this 5 that do not have pairs, so they're not going to come out from under the radical. They remain under the radical. So it's going to turn back into 15. And I have 2 times negative 6, which is negative 12. Here's your caution. Remember, that's a 1 right there. So you have 1 minus 12 for your coefficients to get negative 11, and then your radical doesn't change. It will stay 15. Okay. We also did problem number 3 during the notes today, so let's take a look at it. 7 is prime. It will not break down any further, so I'm going to bring this down. He's not going to change. 10 root 7. Look at 63. 63 can be made one way by 9 times 7. Well, we just said 7's prime, so it's not going to break down anymore, but 9 can be rewritten as 3 times 3. Okay? I have a pair of 3's, which means 1 can be represented on the outside. It's going to multiply to the coefficient that's already there. I have the 7 without a pair. So the 7 is going to remain under the radical. And in front, I've got 3 times 2, which is a positive 6. Same index, same radicand, add the coefficients, so I get 16 root 7. All right, let's go ahead and flip over to the back side of the front page. And there we did problems 14 and 15 and 17. They're a little bit longer because they have more terms. Okay? 14, when I looked at it, there is no like terms to begin with, so we got to start seeing if we can break down. So start with the first term. 6 can be rewritten as 2 times 3. That's not going to help us because there's no pairs, so we're just going to put them back together and bring 10 root 6 down. It remains unchanged. We could not simplify it any further. 150, let's take a look. How about 15 and 10? 15 will break down to 3 times 5. 10 can break down to 5 times 2. And when I do that, I see I end up with this pair of 5's right here. That means 1 5 comes out to the coefficient. So it'll be 5 times 18 on the outside. On the inside, I still have a 2 that was unpaired and a 3 that was unpaired. So that means it's going to be 6 underneath my radical. On the outside, we got 5 times 18, which is a positive 90. And we're not done. This is where it's longer. We're just going to start the whole process over again. We've got 54. Does 54 break down? It can be rewritten as 9 times 6. 9 can be rewritten as 3 times 3. So I'm going to cross him off so we don't look at him. 6 can be written as 2 times 3. Now when I look at this, I have 2, a pair. So that means 1 3 is going to come out to the coefficient in front. I have a 2 and a 3 that do not have any matches. There's no pairing going on, so they're going to stay underneath the radical. So the radical is going to be 6. On the outside, we have 3 times negative 4, which is negative 12. And we have 10 plus 90 is 100 minus 12 is 88, and the radical 6. So it's the same exact process, it's just longer. Let's take a look at 16. 16, we do have a couple like terms right here. These guys are the same, radicand and index. So I'm going to go ahead and combine them first. I got negative 3 minus 5. This could be negative 8, radical 6. Now we want to see if we can simplify these other ones. 8, remember our shortcut with 8, it's 2 times 2 times 2. We do end up with a pair. I have a pair of 2's, which means one's going to come out to the coefficient in front. And we get 2 times 4, which is 8. And there's this lonely 2 right there who's going to stay under the radical. And then 2 is prime. That's as simple as it can go, so we're going to bring it down for root 2. All our index, so they're not all the same. So the only ones I'm going to be able to combine are these 2 guys on the end. So these 2 guys right here. We can't lose him this first term, so we're going to bring him along. Negative 8 root 6. And then I have 8 plus 4 is a positive 12 root 2. Okay? So remember our vocabulary too. These are all irrational numbers because they still have the radical in the answers. If you turn these into decimals, they would be crazy decimals, non-terminating, non-repeating. For our last problem, we want to find the perimeter of this triangle. Remember, perimeter is when you add up all the sides. So they are not like terms, so we're going to have to start simplifying to see if we can combine them. So I'm going to start over here with 2 root 72. 72 can break down 9 times 8. This can break down further. 9 can be rewritten as 3 times 3, and 8 as 2 times 2 times 2. Looking for my pairs, I have a pair of 3's, which means one's going to come out and multiply to the coefficient. I have a pair of 2's, which means one's going to come out and multiply to the coefficient. And then I have the single 2 here. So the single 2 is going to remain the radicand. On the outside I have 2 times 3 times 4, which is 12. So one of my sides is 12 root 2. This guy, he's already root 2. He can't simplify any further, so I'm just going to bring him over. Plus 16 root 2. And then this last side, let's see if we can go ahead and simplify him. We have 8 root 18. 18 can be rewritten as 2 times 9. 2 is prime, so it doesn't go any further. 9 is 3 times 3. So I end up with a pair of 3's. So one's going to come multiply to the coefficient out front. I have this 2. Remember, we use this 9, so let me cross him off. I have this 2 that has no partner, so I know it's going to be radical 2. And in front, it's 3 times 8, which is 24. So my last side is 24 root 2. So I'm going to add that to the others. Same radicand, same index, so the root 2 is going to stay. And we have 12 plus 16 is 28 plus 24 is 52. So 52 root 2. Hopefully this is helpful. I will see you guys on Monday. Hopefully this will help you do your homework over the weekend too. Talk to you later. Bye.